we present SCoFT, a cutting-edge fine-tuning method designed for pre-trained text-to-image generative models aimed at promoting equitable image generation. Given a text prompt, photo of a traditional building followed by a specific culture, the current text-to-image generative model Stable Diffusion generates images that vary in culture accuracy. Notably, images of many cultures often perpetuate stereotypes and portray offensive representations. For instance, Nigerian viewers might find that their traditional building is depicted in a way that inaccurately suggests poverty, misrepresenting the region's true character. We show the images generated using our pipeline are more accurate and depict less offensive representations for different cultures, as verified by viewers from native individuals. Here comes another example. Given a text prompt, two people wearing traditional clothing followed by a culture name, Stable Diffusion often fails to accurately depict culture elements and may even confuse similar cultures. For instance, it might misrepresent Korean traditional clothing as Japanese clothing, which could be highly offensive to Korean viewers. By employing our SCoFT method, generative model gain a deeper understanding of culture context, generating more accurately culture images. Many culture misrepresentation issues can be attributed to the use of large training datasets. Addressing these issues by training a text-to-image generative model from scratch remains impractical due to the difficulty of acquiring a large volume of purified culture data. Previous efforts to customize text-to-image diffusion models have focused on injecting simple objects or editing easily describable concepts. However, the concept of culture is more abstract and presents a greater challenge in defining a clear image editing direction. We propose to awaken the existing knowledge within the model using a small yet precise amount of cultural data to enhance cultural accuracy. We introduced the Cross-Cultural Understanding Benchmark dataset, the first culturally aware text-to-image dataset created by individuals who identify themselves within the culture. Here are some examples from our culture dataset. After gathering a small and culturally specific dataset, our goal is to encode these culture concepts. Direct fine-tuning with the COP dataset often leads to overwriting due to its small scale and detailed prompts. We address this with a memorization loss using regularization prompts, reducing direct mapping between images and texts. Our results demonstrate reduced memorization and increased outcome diversity. Fine-tuning a latent diffusion model involves manipulating latent features. We denoise this feature through iteratively sampling and decode them into the pixel space. We pose a question: can we use the intrinsic biases of a diffusion model, which often produces culturally inaccurate images, to refine its outputs? To do this, we use our COP images as positive examples and employ the pre-trained depth control net to evaluate the model's understanding of the same objects. With proper filtering, we create a set of negative images that highlight the model's biases. During fine-tuning, we use self-contrastive techniques to direct the images towards more accurate cultural representations from the COP dataset, moving away from the less accurate images due to the model's misconceptions. During backpropagation, the gradient is selectively recorded to enhance the computational efficiency and improve the fine-tuning performance. Here, we present the result from each component of our SCoFT pipeline. Our method effectively reduces stereotypes and yields less offensive outcomes. We also demonstrate two additional examples. After applying the SCoFT method, we observed more accurate and respectful representations. Additionally, our human evaluation results show that images from Stable Diffusion were often ranked worst due to the stereotypes and offensive content, while those from SCoFT method ranked first for culture accuracy. For more results and details of this work, please visit us at CVPR or check out our project page. Thank you so much for listening.